Wind turbines are massive and have many moving parts, making them difficult to install and maintain. But what if we could harness wind power with something smaller and simpler, like something that could fit on your roof? Or maybe even something with no moving parts at all? In this video, we explored the exciting possibilities of solid-state wind energy, envisioning a future without blades. Introduction of bladeless wind power. Wind power has been on the rise, with a whopping 93 gigawatts installed worldwide in 2020. Despite this growth, traditional wind turbines encounter significant hurdles, such as expensive initial investments and negative effects on the environment. Enter solid-state wind energy, a groundbreaking solution poised to revolutionize the way we harness wind power, especially on a smaller scale. Traditional wind turbines, with their towering blades and intricate mechanics, have served as the face of renewable energy for decades. While they have contributed significantly to reducing carbon emissions, they come with drawbacks that limit their widespread adoption. The upfront costs of constructing wind farms can be prohibitively high, deterring many potential investors and homeowners. Also, the construction and operation of these turbines can disrupt local ecosystems and pose risks to wildlife, particularly birds and bats. The concept of solid-state wind energy offers a promising alternative to traditional wind turbines. By eliminating the need for blades and complex mechanical components, solid-state wind generators aim to streamline wind power production while minimizing environmental impacts. This innovation opens the door to harnessing wind energy on a smaller, more accessible scale, making it feasible for individual homes and urban environments. Imagine a future where compact, bladeless wind turbines dot the landscape, quietly and efficiently generating clean energy without the need for sprawling wind farms. This vision of sustainable energy production represents a significant step forward in our efforts to combat climate change and transition to a greener, more sustainable future. Bladeless wind power promises to democratize access to renewable energy, empowering communities to take control of their energy needs while reducing reliance on fossil fuels. As we look ahead to the future of energy, solid-state wind technology stands out as a beacon of hope for a cleaner, brighter tomorrow. Challenges with traditional wind turbines. Traditional wind turbines, despite their impressive contribution to global wind power capacity, come with a set of challenges that hinder their widespread adoption and effectiveness. One significant hurdle is the high upfront costs associated with the construction of wind farms. These costs act as a deterrent for potential investors, making large-scale wind power projects financially burdensome. Traditional wind turbines are not tailored for individual homes or small-scale installations. The energy generation model that proves successful on a large scale falls short when applied to a residential setting. This limitation prevents widespread integration of wind energy at the individual or community level, hindering the potential for decentralized, clean power solutions. Another concerning aspect of traditional wind turbines is their impact on wildlife. The construction and operation of wind farms have been associated with harm to birds and bats. While estimates indicate significant bird fatalities at wind farms, context reveals that other human-related factors, such as domesticated cats and collisions with windows, contribute to a much larger scale of bird mortality. Nonetheless, the impact on wildlife remains a valid concern and calls for innovative solutions that mitigate harm to ecosystems. In light of these challenges, the future of wind energy is shifting toward alternatives that address the downsides of traditional turbines while maintaining eco-friendliness. Solid-state wind energy emerges as a promising solution, eliminating the need for large moving parts and reducing maintenance costs. This innovation opens the door for a more accessible and sustainable approach to harnessing wind power, paving the way for a future where clean energy is both effective and environmentally responsible. Ion wind generator, UECON. The ion wind generator, known as UECON, electrostatic wind energy converter, stands as a groundbreaking concept developed by researchers at Delft University of Technology in the Netherlands. Unlike traditional wind turbines with intricate moving parts, Rjukan represents a shift towards solid-state wind energy, eliminating the need for cumbersome mechanical components. At its core, Rjukan relies on the principle of electrostatics to harness wind energy efficiently. By utilizing wind to create a flow of charged particles in the air, the system introduces a unique approach to electricity generation. In this innovative design, water droplets are employed to hold a positive charge. As the wind passes through these charged droplets, their movement generates electricity, which can then be seamlessly transferred to the grid. One of the most compelling aspects of Rjukan lies in its potential to revolutionize the landscape of wind energy. The removal of moving mechanical components translates into a considerable reduction in maintenance costs, minimizing wear and tear on the system. Additionally, the absence of traditional turbine noise issues enhances the overall appeal of Rjukan as a sustainable and environmentally friendly energy solution. While still in the developmental stages, Rjukan holds the promise of becoming a game-changer in the field of wind power. Its ability to tap into the charged particles produced by the movement of wind opens up new avenues for efficient electricity generation without the complexities associated with conventional wind turbines. As the pursuit of cleaner and more accessible energy sources continues, Rjukan emerges as a hope of innovation, offering a glimpse into the future of solid-state wind energy. Solid-state wind energy transformer, SWET. Richard Epstein's solid-state wind energy transformer, humorously named SWET, presents a revolutionary approach to harnessing wind power. The key innovation lies in the utilization of ionic currents through a process known as electrohydrodynamics. In the prototype construction, Epstein employed parallel aluminum wires standing between two tall wooden masts. These wires served distinct purposes. The attractor wires, resembling plane wires, and emitter wires, equipped with small tufts of 7-micrometer diameter carbon fibers. When a small negative current flows through the emitter wires, the tufts create a coronal discharge, releasing negative ions into the air. This electrohydrodynamics process mimics the principles seen in ionic air purifiers, with wind blowing past the wires carrying the negative ions, resulting in the entire array obtaining a slight positive charge. As a consequence, electrons flow from the ground, offering a viable source of electricity. The significance of SWET lies not only in its potential for electricity generation, but also in its environmental advantages. The reduction of moving parts in its design translates to lower maintenance requirements, addressing a long-standing challenge faced by traditional wind turbines. The absence of traditional turbine components mitigates wear and tear, contributing to increased longevity and sustainability. SWET, with its ionic current approach, emerges as a promising alternative, showcasing the potential to transform the landscape of wind energy. As the world seeks more eco-friendly and efficient energy solutions, Epstein's innovative solid-state wind energy transformer offers a glimpse into a future where electricity generation aligns seamlessly with environmental consciousness. Innovative designs. Vortex Bladeless introduces an innovative cylindrical design for wind generators, utilizing vortex-induced vibration resonance. This unique approach minimizes traditional wind turbine drawbacks, offering reduced maintenance, increased bird friendliness, and cost-effectiveness. The cylindrical structure harnesses wind energy through oscillations, eliminating the need for traditional rotating blades. This design not only addresses environmental concerns, but also presents a cost-efficient solution for sustainable energy production. In urban landscapes, the PowerPod emerges as a small-scale wind turbine designed for efficiency and safety. With an enclosed blade system, it ensures reduced risks for birds, pets, and wildlife. Also, the PowerPod's advanced blade design accelerates wind speed, enhancing its power generation capabilities. Its adaptable installation on various structures, such as rooftops and fences, makes it a versatile option for urban areas. Offering the potential for 24/7 operation, the PowerPod complements existing energy sources and marks a significant step towards integrating wind power into everyday urban environments. In the end, let us know your thoughts in the comments section below. Also, don't forget to like this video and subscribe to the channel. Meanwhile, thanks for watching.